So this is the weather station sensor that's been on our roof for about 20 years, and it stopped working. I lost the weather station display itself many years ago, gave up on it. But this has been on the roof squeaking away, and yeah, interesting. I mean, it's actually survived pretty well. All the screws are stainless. This shaft is stainless. Plastic's obviously UV affected. It's gone sort of matte, but it's okay. There's a screw here which I've taken out. 3 screws, again stainless around the edge. That's all bone dry inside. It's kind of got this double cover really. This keeps the weather out of this area, which is sealed against here with an O-ring. The direction is picked up by this sort of sector 4-bit, 1, 2, 3, 4-bit sensor, this little pickup arm here. So that's quite neat, picking up the wind direction. The speed, this thing's long gone, it's gone really stiff. But I believe that's a magnetic sensor, so again there's no moving parts apart from the spinning vane itself. This whole assembly can come out now. So again, bone dry inside, pretty well sealed. I've obviously bent that shaft getting the anemometer off, but yeah, interesting. Okay, so there's a wire here which comes down. There we go. Oh, that could be a thermometer, couldn't it? I think that's a thermometer. So how does it pick up the rotation of this, which of course is dangling down here somewhere? So there's the 4 LEDs, I guess, for picking up the position of the wind direction with 4-bit resolution. So let's break that off. Whoops. Actually, I wonder if that's just brightness. Could be. It looks like the 4 LEDs are shining through the PCB. There's a detector here, a single detector, and a light pipe. So I think it might just be the brightness. All those, the number of LEDs it can see gives it one of 4 brightness levels. There's the rotor. So yeah, I guess if you're around here, for instance, you've got 4 LEDs visible, whereas here you've got none. So I think that must be it. It must be 4 brightness levels. It's pretty cool. Cheap and cheerful. Not sure what those contacts are. Obviously it's where this comms cable comes in. Some lettering on there. Ground. Nothing especially obvious. But how does it get the speed of the wind? There's obviously no electrical contact between this and the rest of the housing. These are actually ball bearings, would you believe? Tiny ball bearings on either side. So that's pretty cool. And again, no expense spared, by the looks of it. Quite impressive, really. So this is quite a neodymium magnet. I can't pick up any magnetism in here at all, either in the casing or in the impeller itself, or the rotor at least. And none of these appear to be magnetic. This obviously the shaft is stainless steel or some kind of ferrous material, but no magnets, so it's not doing it by Hall effect sensor or similar. So how is it doing it? I think it must be capacitive. And this has some cleverness to it. I think there's obviously some copper there, the green. I think this might be two separate conductors. This is the spindle that protrudes down into this housing, like so. So is it possible that as the rotor blades pass, it changes the capacitance seen by this pair of conductors? That's all I can think of at the moment. This sits in the where does this sit? It sits through here and into there. So it seems too low down to well, it could be, I suppose, couldn't it? But how does the signal get from this to this board? There's some evidence of wear there, which is off the bottom of this wind direction disc. But there's a crystal there, so there's obviously some timing going on. A blob. But there's no obvious sensing element around this hole. Bearing in mind this is going to be here somewhere. So maybe this, no, there's only two wires going to this sensor here. So I guess it could be that the thermometer temperature sensor is on the board, which would make sense. And this is the pickup, which would put it here with a little drain hole. In which case that would be there. But as this rotates, that's going to be in a different place with respect to the rotor here. There you go, that's where the rotor should be. So that'll be there. So yeah, I mean that doesn't make sense to me, or does it? No, I mean if that's there, the position of this relative to the rotor is different than if it is there. It's quite different. So it doesn't make sense that that is the sensor other than for temperature. So yeah, I'm really interested now, and would love to know if anybody can come up with a mechanism for this working. So yeah, because we've got this impeller running on two ball bearings inside a completely magnet-free housing. The impeller is magnet-free, or the rotor, and so this is suspended below this part, which is stationary, and it just fits in there on this spindle, which fits through here. So yeah, so this whole lot is moving around with the wind, with this weather vane, wind vane, with a D-shaped recess in there, which fits onto the D-shaped stainless steel shaft. So yeah, it's picking up the wind direction with this 4-bit disc. So work that out, that's okay. There's a temperature sensor down here which is picking up through this hole here, but how on earth it picks up the wind speed, I'm really not sure. So all I can come up with is it's a capacitive effect between the rotor and the end of this spindle, which does seem to have something slightly complicated going on down here. Possibly that part is interdated from that part, but I'm not entirely sure. And even if it is, then the circuit board is way up here. So how does that work? There's no sign of any sort of components on here which are obviously Hall effect sensors or anything of that sort. So there is a crystal, so there's obviously a timing element, so that would work for measuring speed, but something hidden in here. But yeah, so no obvious Hall effect sensor or something similar that would pick up the speed from this rotating anemometer. So yeah, if anybody knows how, please let me know. I'd love to know. Thanks for watching.